Okay, we're back. Tech Math 2. We're working on complex numbers. We're in the red book, page 452. So we're looking at putting 27. This is in polar form. So remember, polar form gives you the length of the vector and the angle that it goes off on. Rectangular form gives you a XY coordinate of the endpoint. And so we've worked with these already, but not with complex numbers. So remember the complex number system, this is x-axis is the real axis, y-axis is the imaginary axis. And so when I have 8 plus 6j, that's actually 8 comma 6. It's like an x and a y value, all right? And so they want me to just do the shorthand for that. That's easy enough. That it looks like this. It's 27.5. That's the length of the vector. And then you do this big angle mark like this, and then put the 288 degrees in there, like so. Okay. So that's just 60. They just wanted the shorthand. I think on 61 they also just wanted the shorthand where they wanted rectangular form. They wanted to write 8 plus 6j, and then polar form. I'm pretty sure they give you those two values already on the picture. They tell us 37 and 10. But let me show you how we get that. We're going to take this xy, and if you remember on your calculators, again with the calculator, we're going to hit second. And then apps, that's the angle. And that's going to bring up a screen that looks like that. And so what we want to do with this is go from rectangular to polar. So if you go R, rectangular, R to P sub R, that's going to give us the R value. Hit enter, and then put in your XY. It's 8 comma 6. So I typed in 8 comma 6, so when I hit enter, that tells me 10. So this is telling me that the length of the vector here is 10. And then that was off of the 8 comma 6. So now we can also use the same thing, second, apps, and then down to rectangular to polar, theta. So I'm changing it from rectangular to polar, theta, hit enter, put in your 8 comma 6, and that's 36.86. We'll just make it 37 degrees. So again, if you recall back, way back, first couple of weeks of the semester, we did problems where they gave us two vectors. We had to convert it from polar to rectangular, add up the x's, add up the y's, and then convert it back to find the resultant vector. This isn't that complicated. This is just, you have to remember 8 plus 6j is 8 comma 6. And so you can take it from rectangular and find the polar. And so in rectangular form, it would be 8 plus 6j. In polar form, it would be 10, and then that big angle mark with 37 degrees inside the angle. These are basically saying the same thing. 8 comma 6, that point right there. 10 angle mark little thing, 37 degrees is 37 degree angle with a length of 10. So rectangular, polar, with complex numbers. All right. Let's take a look at 10.8, number 70. Go to 10.8, number 70, and let's see what they want us to do there. Here, C3PO, hold my calculator. All right, rectangular form of 20.4, 20, angle 40 degrees. So this is polar, but they want the rectangular. They want me to find the rectangular form of those. So let's find that. So we're going to do from polar to rectangular x, and type in 20 comma 40, and then we're going to do polar to rectangular y, and type in 20 comma 40. So 20 r, and then comma, and then the angle. So the upside of this shorthand, when you're changing it from polar to rectangular, you get to put it in the same order. You just have a little comma in between it. All right, so we're going to go to that calculator again. We're going to key in second apps. We're going to go down to polar, rectangular x. Do you see it? And then we're going to hit enter, and then we're going to put in 20 comma 40, and then we're going to hit enter. 15.32, how many places they want it to tenths. So 15.3. And then polar to rectangular y, that's actually off the screen. You got to click down one more. 20 comma 40. And that's 12.85, so we'll make it 12.9. All right. And now they want it in rectangular form. So remember, it's complex number. So this, remember how xy works. X is the real number axis, and y is the imaginary. So we write it 15.3 plus 12.9j. So instead of how we normally would write coordinates, 15.3 comma 12.9, we're not doing that anymore because it's the complex number system. So that's real, that's complex, and there we go. All right. So again, something that we've done in the past, we're calling back on now to make it work here. Some of these you don't need a calculator to do it at all. If they use 90 degrees or 180 degrees or 270 degrees, you can just figure out the coordinates from that. And so I guess we could demonstrate one of those. We'll look at 75 really quick. And so we can put the calculator down. We don't really need the calculator. We'll do 75. I should completely understand this stuff. And so with 75, they have 5, 180 as their polar coordinates, and they have 5, 270 as their polar coordinates. And you really don't need a calculator to do these, because look what's going on there. Let me do the graph. So 5, 180. 5 is the length of the vector. That's 5 right to there. And so this is, and that's 180 degrees. And that's 5. And so if we do the coordinate of that, that is -5, comma 0. Because we just done the xy as an xy, that's the point at the end of the vector. And so that would be -5 plus 0j if I wanted to put it into rectangular form. And so I don't need the calculator to figure that out. You could do the calculator if you really wanted to, and you wanted to, go polar to rectangular x and put in 5 comma 180 and then hit enter, and it'll kick out -5. And if you go polar rectangular y, 5 comma 180 and hit enter, it'll kick out 0. But you really don't need that at all if you know how graphs work. Same with this, 270, right? Same dog, different fleece. So we're going all the way to 270, and they want 5. And so when we look at that point, that would be 0 comma -5. So this would be 0 minus 5j. Okie dokie. So that is 10.8. Next video, we'll do 10.9.